Yes, welcome again to the session strength of materials to the chapter stress and strain. Myself is Prasanna, lecturer in mechanical engineering, Government Polytechnic, Mulbagal. Today, I will be going to discuss in this session of the simple stress and strain. What are the contents we have been discussing about the linear strain, lateral strain, Poisson's ratio, factor of safety, and volumetric strain. In the previous sessions, we discussed about the various strains which has been acting. But in this case, we go for the particular strains, that is the linear strain will come across the linear strain. See, as the name only implies, the linear strain, it is acting only on the length related matter. Okay, it will be dealing with the length related matter, whether it may be a deformations acting per unit length by unit lengths or by the original length. So what is the strain which may be causing the tensile strains, as well as only the tensile strains will be causing the linear strains. I think when we go for the lateral strains comes under the category of the change in dimensions. It comes under the category of the change in dimensions, which may be a breadth, which may be a depth, which may be a thickness. That is, the entire dimension is nothing but the entire area. It depends upon the entire area what we have been did it. It comes under those category of the lateral strains. And the Poisson's ratio, it is the having the new symbol, that is lateral strain. Lateral strain, linear strain is also called as the longitudinal strain. Okay, linear strain is also called as the longitudinal strain. And the factor of safety as well as volumetric strain. Again, the volumetric strains will be coming. There is the change in volume. Okay, the change in volume by the original volume. Change in volume is delta V. That is the deformations which is acting in the certain area. Right? Yes. First content, we go for the linear strain. Yes. You can see in the right side, right? In the right side, there is the material. Okay. That is the large L. Okay. You can see the large L. That is the original length. That is the original length. In this, what happened? The material, it has been subjected to the two tensile loads. That is the tensile load, that is the forces which acting the P at the either end and the P at the this end. This load tends to pull the material, right? It tends to pull the material at the either force. This tends to change the length. How it has been happened? Due to the tensile stress. Due to the tensile stress which has been induced in its body, it makes the body to tense, to pull towards the either force, it causing the length to increase. There is a changes in the length compared to the original length. It changes its length from L to the delta L. That is what happens, it decreases the area. It decreases the area, whereas it tends to change the area. You can observe in the figure, whenever a body of the length L is subjected to axial force P, as shown in the figure, it causes the deformations. Okay, the deformations per unit length in the direction of the applied force is called as the longitudinal strain. The linear strain is also called as the longitudinal strain, that is the deformation which is acting per unit length in the direction of the applied force. It is called as the longitudinal or linear strain, right? In this category, the linear strain is also given as delta L by L, that is the change in length by original length. The change in length is briefly given by L plus delta L or delta L minus L divided by original length. This is the changes. Okay, next we go for the change, right? Changes in the linear strain. What we have been been clearly mentioned. It has been given as B and D. That is, B is mentioned as the breadth and D is mentioned as the depth. Okay, whenever the B changes, that is the breadth changes, takes place, right? In this linear strain, whatever in this lateral strain, sorry, in this lateral strain, compressive forces will be taking place. Compressive forces, it will be taking places, right? Compressive forces. Which types of the forces? Only the compressive loads. Corresponding to the compressing force, there is a pushing force. The material tends to push. So that what happens? The diameter will increases, right? The diameter will increases, whereas the length decreases, whereas the breadth and the diameter will increases. As been shown in the figure, whenever the compressive load is when acting at the either end, at the left or the right, so that what happens, there is a change in dimensions in the breadth as well as the depth, which causes the d2 d minus change in diameter, that is d minus delta d, and whereas which we go to observe in the B is B minus delta B, that is the lateral strain. Okay, in this figure, what happens in this figure, whenever a body of a diameter d is being subjected to axial force P, as shown in figure, the body increases its length simultaneously, which causes to decrease its diameter in the direction normal to the directions of the applied force. Then the strain normal to the direction of the applied force, it is called as the lateral strain. That is given as the lateral strain is change in diameter divided by original diameter, or change in breadth divided by original breadth. Once sometimes in some of the cases what happens, this diameters or the breadth, it will be in the three dimensions. In this three dimension, it will be considered, or the thickness also. Okay, so that this thickness also will be considered, that is the delta t. Delta t divided by t, that is change in thickness by original thickness. Finally, the lateral strain is given by delta d by d, that is change in diameter by original diameter, delta b by b, this is change in breadth by original breadth, delta t by t, that is change in thickness by original thickness. This is the comparisons of the lateral strain and linear strain. The linear strain is also called as the longitudinal strain. Yes, we go for that topic. Right, see, next topic, it can be in, yes, this is also again you can easily understand what is the lateral strain and the longitudinal strain. It has been clearly vision. See, there is a material, if you pull towards the right side as well as the left side, so that it creates the longitudinal strain, that is nothing but the linear strain, that is the change in length by the original length, right? It causes to increase its length but decreases in area. It has been clearly observed in the figure. You can observe whenever the tensile stresses or tensile strain will occur, what happens? It increases its length, whereas it decreases its area. Again, whenever that lateral stresses like compressive forces is been applied, it decreases its length but increases its area. It increases its area. That is the difference between the longitudinal strain as well as the linear strain. Okay, next we go for the topic Poisson's ratio. Yes, what is this one, Poisson's ratio? Why we know that the symbol has been given as the Poisson's ratio, right? The Poisson's ratio, it has been given the symbol as Poisson's ratio, right? When a body it has been stressed within the elastic limit, yes, when a body is stressed within the elastic limit, the ratio of the lateral strain to the linear strain or the longitudinal strain, it is called as the Poisson's ratio. It is denoted by the symbol nu, that is 1 by m. Okay, this is the Poisson's ratio. Normally this Poisson's ratio factors in the point division 2.5 to 4, like that, 0.25 to 0.4, that is the limits. Okay, next we go for the factor of safety. This is the factor of safety, that is the ultimate stress acting on the working stress. Why we need this one factor of safety? Yes, we see any material, if you come across the any material, there is some constant, there is the ultimate load. Once it crosses the ultimate load, the material, there is a chances of breakage. So that in order to avoid those things, there is a FOS, that is the factor of safety will be given for each material. It is being given as ultimate stress divided by working stress, right? Next we go for the topic volumetric strain. Again, yes, we have been discussed what is tensile strain, compressive strain. Again we have the volumetric strain. The volumetric strain, it is also the same thing. Whenever the material which has been subjected to a compressive or the tensile or the shear or tangential or the bending loads, so that what happens, it alters the volumes in the material. So the once it alters the volume, there is a causes of changes in volume occur. Therefore, those volume alteration is called as the change in volume which has been occurred. That is given by delta V by original volume. Okay, always its unit of the volume is meter cube or centimeter cube or millimeter cube, right? Yes. Yes, in this content we came across deeply about what is the strains which has been occurred, that is linear strain, longitudinal strain or longitudinal strain, lateral strain. Why this occur? Depending upon the compressive forces, there is a diametrical changes like breadth, depth and thickness in the lateral strain, whereas in the linear strain we have the only the change in length will be occur. In the volumetric strain only the volume will be occurred. And we come of course the Poisson's ratio. What is lateral strain by linear strain? This is called as Poisson's ratio, denoted by nu. A factor of safety for every material once without at the final stage in the breaking point, the material will, there is a chances of breaking. So that for the to avoid those breaking, there is a ultimate working stress and the ultimate stress is there. This is the factor of safety and the volumetric strain. Yes. Now the next content, we go for the multiple choice questions. Factor of safety is tensile stress. Option A is tensile stress per permissible stress. Option B is compressive stress by ultimate stress. Option C is ultimate stress by permissible stress. Option D is ultimate stress by shear stress. Option, which is the options? We go for the option C, ultimate stress by permissible stress. Yes, we know that factor of safety is given as ultimate stress by working stress. Number 2, volumetric strain is A, increase in length by original length, decrease in option B, decrease in length by original length, option C, change in volume by original volume, option D, all of the above. Now only we discuss the option C is change in volume by original volume. The volumetric strain is given as change in volume by original volume. Poisson's ratio. Third question is Poisson's ratio is nothing but longitudinal strain or lateral strain by longitudinal strain. It is given by lateral strain by linear strains. Yes, this is the correct option. First question, the option is because ultimate stress by permanent stress, volumetric strain is change in volume by original volume. Poisson's ratio is lateral strain by longitudinal friends. Thank you, friends.